specifically for Project AIR, which is a project that we have under TIBCO Labs, and that allows you to have edge technologies and do a lot of stuff that I'll be talking about. I'm also going to play a quick demo that Marcelo Gallardo, one of our team members, have prepared for us that involves computer vision at the edge with a cool mask recognition machine learning model. Just a quick confidential disclaimer for some of our products to be considered. So the agenda for today is it's pretty simple, right? Like I'm going to talk a little bit about some of the use cases and areas of impact if you're considering or you already have an Internet of Things at the edge or edge technology stack, right? And then we're going to dive a little bit deeper into our project overview. Why do we need a project like this in TIBCO, and how it actually interacts with some of our products, projects that we have run, and how powerful that can be. I'm going to dive a little bit deeper as well on the architecture, and we're going to play a quick demo that showcases some of those functionalities. So basically, what happens in the Internet of Things, right? Like when you're starting to have an Internet of Things strategy, you're going to have to ask yourselves a few questions, right? Because Internet of Things, it changes a few of the paradigms that you're going to have, right? Like you've probably already done a little bit of cloud migration. You have some of your processes at the cloud, and now you're thinking about doing some of that computation at the edge. And there are some things that you're going to need to consider, right? Like, are you using your data efficiently? Are you integrated with the Internet of Things, right? Are you integrated with the real world, with the analog world? And can you process and analyze the data everywhere, right? So those are some of the questions that you're going to have to answer. Just to start, and to give a little bit of an overview of how important edge computing can be, it's an actual horizontal, right? Like that touches on almost every single industry, because every industry is going to have some sort of like interaction with the real world, right? So once you start interacting with the real world, there's some data there that you're not capturing if you don't have an Internet of Things architecture, right? So for instance, let's say you have connected vehicles as part of your business, right? Like you have vans going around delivering things. How you automate that driving and improve safety is one of the quick questions that you have to answer yourself. Telemetry of all those fleet management systems that you can efficiently have better transport, have better tracking of those devices, etc. Right? So it applies to logistic and supply chain management in a big manner, and also in the automotive sale. Like if you have any kind of like automotive devices, it's going to apply to you, right? Also as well in transportation and fleet management, as we said, right? There's another big point as well in predictive maintenance. If you have any kind of product that is perishable, or it can break with the time, which is pretty much everything, then you can leverage sensors and cameras that reduce the failure and actually predict that maintenance and tell you when those products are about to break, or they're very likely to break, without having to wait for that, and eliminating any downtime as well. There is a big point as well in terms of compliance, where you can have analytical insights on your customer, and depending on these ever-changing regulations, you can adapt very quickly, right? So you can program that adaptability instead of having to just physically go there and change things as new regulations come along. So that's an important one. When we're talking about smart metering, we're talking about, okay, how can you easier and more effectively measure some of the analog world, right? And bringing all that data back to your business services in an automated way. And talking about automation, you can basically have Internet of Things devices interacting with each other, right? Meaning that you can pretty much automate everything. Once you're in the analog world and you have these devices, with sensors and different capabilities and power at the edge, then you can automate in a much better way. Also, in terms of like retail and consumer goods, you can actually do a better tracking of your assets, right? Because then you are generating data right at the edge, meaning that you don't have to go and enter it yourself, right? It's captured and generated by the devices itself. So we pass on the next one. Okay, there you go. So let's start a little bit about what is edge computing, right? So as we said before, everybody or almost everybody is already done their cloud strategies. That's a mature technology that meant a lot of things, right? Like you have to change the way you containerize things. You have to separate the state from the actual computation. You have to have your cloud provider capabilities, infrastructure as code, etc., etc. So sort of like the same thing, same journey is happening when you're starting to have edge computing capabilities, right? Some of the paradigms and best practices have changed slightly. So for instance, without the edge processing, your Internet of Things data is transferred to the cloud, right? Where the processing is happening there. So you have a lot of latency there happening because the data that is transferred can be very heavy, right? So can you transfer a big amount of data to the cloud? That's the first question you have to answer, right? Like let's say you have machine learning and you're actually feeding video all the way up. If you're doing all that and then running those machine learning models, you have a big latency there to account for. So can you afford that? Also, any identified threats and opportunities from the data processing are communicated back all to the IoT device, right? So all those misses responses on that flow of data going all the way up to the cloud is something to account for. So when you're talking about now having edge processing, what you're bringing is the power all the way down and the compute all the way down to the device itself. So as soon as the actual device is capturing that data, you can start processing it, right? And that like super powerful. And with this ever growing power at the edge, like this better compute, better storage, better memory, etc. It's becoming like really important to have your edge computing strategy, right? As we said. So now instead of just transferring your data all the way up to the cloud, for instance, in the same example as we said before, you're going to be able to compute right at the edge, right? So any threats and opportunities are right identified locally, and the action can take almost immediately, right? So then you can have a hybrid approach where the data is transferred only as needed. So you can either transfer it or just, for instance, in a machine learning model for computer vision, you might run your model and then just stream some of those frames, right? That actually score some results. And we'll see some example at the demo, right? Where let's say you're identifying people with mask on or off. You can actually do your machine learning model at the edge, and then just whenever you score something and there is a mask result, send that frame all the way up to the cloud. So some of the challenges and things to take into account when you have an edge computing strategy is, okay, what are the privacy and security challenges, right? Like it changes slightly from the cloud to the Internet of Things. Your encryption mechanisms are independent of the cloud, and you have limited resources for security practices, right? Even though the computing is growing, you have almost unlimited computing at the cloud, while at the edge still very limited, right? Because it's the physical location that you're going to do it. You have scalability considerations as we're talking about. So a different kind of devices and heterogeneous notion of it has an energy constraints, etc. You can have reliability issues. Some of the devices are might be down, so you have to have failover management, fault tolerance, etc. All that in the cloud is slightly less impactful, even though you also have to take into account some of that, right? But it's kind of like a different model at that point. You also have to look into speed improvements. Okay, so now it's always a trade-off, right? Like when you pass, let's say you stream your data all the way up to the cloud, you have almost unlimited resources to run your computer models, a little bit in parallel, etc. While at the edge, you have less latencies streaming the data, but then you also have real time, almost real time, because you are right there at the edge, right? And that touches on efficiency gains. So all your analytical and artificial intelligence tools can run right at the edge, right? That gives you a set of benefits as well. So that's kind of like a general idea of what edge computing is, right? And how some of those changes you have to take into account, right? So that's why we created Project Air. At TIBCO, we have a set of really powerful tools and products that allows you to move the data around. You can actually store it. As we've seen, we have toolkits that allows you to have really powerful applications in the cloud, and all this set of like analytics tools to actually analyze that data, right? So very comprehensive set of different tools that you can do pretty much everything. But there was one thing that it was missing, right? How to capture data from devices. So there was a need there for us to go right at the edge and capture those set of data, and not only capture it, but actually process it and then analyze it. And then once you have it in your cloud or in your business environment, then you can do all these set of different ranges of functionalities that we talked about, right? So Project Air, on a nutshell, allows you to register and interact with all those IoT devices, right? Once you have an edge strategy set, you're gonna first need to know where your devices are, where your gateways are, where your edge devices, your sensors, and all those different devices are producing data, right? So what are you gonna do with that data? Project Air allows you to decide what are you gonna do with that data, how you're gonna process it, right? You're gonna say, okay, this is my source, which could be a sensor in a device somewhere in your factory. And I'm gonna create what is called data pipelines that allows me to have a different set of steps that allow me to decide what to do with that data, right? For instance, you can actually get it from a device, you can filter it, you can apply an inference model, and with the result, store it somewhere else for analytics purposes. That could be a very quick example, but it's really customizable, right? Like you can create your different pipelines. Then some of the main components is that we take an agnostic approach in Project Air. We run on top of Kubernetes and standards. Everything is containerized, so you can run pretty much on every cloud provider, anything that runs in containers, right? You can own and analyze and store your IoT data as needed. So you basically own everything. You own their infrastructure that you can deploy in your own cloud provider. You own your data because you decide where you're going to store it, where is your source, and what is your target. And you can process it and analyze it any way you want, right? So we have also an extensible model where every single layer is extensible that allows you for easy integration with other platforms. We are powered by some of our open source technologies like Flogo is like a core component. We have cloud starters, like in the previous session, that allows you to create really powerful cloud applications. And we are actually optimizing for computer vision at the edge. So we have a couple of modules there that allows you for easier deployment and inferencing of computer visions right at the edge. So basically the value proposition, as we said, just to recap, is register your devices, process it, regardless of where the source is coming from, and you compute at the edge, right? Like, so you can deploy these pipelines that are basically application logic right at the edge or at the cloud. or have a hybrid, right? So you can actually have your computer vision models at the edge and then send that data all the way up to the cloud with a pipeline. And then you can actually keep going and doing some cloud computing as well as part of Project Air definitions, right? So you have, as you can see, some resulting business outcomes out of that, right? You have full automation of your processes at the edge and at the cloud. You reduce the risk and add more visibility because you own the whole infrastructure end to end. There's no black boxes here. Everything, most of it, it's open source, if not all of it, and you can decide to actually join it with your products that is your business model, right? So Project Air is fully open source, and you can see every single line of code from the edge all the way up to the cloud, right? So you improve your workflow and reduce the latency and increase performance because you can choose where to put your compute, right? You can compute all the way to the edge, and you can send data to the cloud when you need a little bit more functionality and more power, basically. So just to quickly go over some of the capabilities, you can connect and extract the data for processing. You can manage that data and see where it's going to go and what you're going to do with it. You can create triggers and pipelines, full pipelines to respond to those IoT events. You can feed into long-term big data repositories, anything basically. You can plug and play your different repositories, and you can store your data wherever you want, right? You own that data. You can visualize and explore that IoT data, having any analytics on top at the edge and in the cloud. And you can monitor via customizable UX, right? That we said we leverage cloud starters for your UI, so you can customize it the way you want. You can combine IoT data with AI ML models, and then you can map and integrate with various endpoints within your organization, right? So just really quickly, we are leveraging on HX Foundry, which is an Internet of Things platform by the Linux Foundation. That is an open source platform that unifies IoT edge and computing, having 4 different layers that allows you to plug and play and extend some of that, right? We'd allowed you to have fast time to market, and very solid framework for data normalization at the edge, right? So basically, just to run a little bit some of the components, right? To have a little bit of a visual representation of how an Internet of Things distributed architecture might look like, right? You have 3 main components, even though you can add different bits and pieces here, but these are the main core components that you're gonna have. Starting from the left, you're gonna have your IoT edge computing, right? And that's kind of like the most newest thing if you're starting with your edge architecture, right? You're gonna have your devices and appliances, which is your analog world, which will have sensors and actuators, right? They will be sensing, depending on their capabilities, different things, temperature, they'll be sensing video, basically, or every different things, right? And you're going to configure all that. Then when you want a little bit more power, you want to aggregate all those devices and sensors, you're going to have what is called a gateway, right? The gateway is sort of like your management compute that will have a bigger machine and bigger compute capabilities that manages all those devices, right, and sensors. And then you're going to have some events and data generations happening, right? So that's kind of like right at the edge, right? Then you're going to have an IoT platform that you're going to have to basically deal with that data ingestion, the data management, the device platform management, etc. And then once you have all that data all the way up to the cloud, then you're talking to your enterprise level. So Project Air sits right in between, right, where you actually register your devices, your sensors, etc., and then you define how your data ingestion is going to happen, how you're going to manage that data, and how you are going to pass the data all the way up to the enterprise, and allows you also to interact through the extension points with your business applications as well, right? So just the last one, just to dive a little bit deeper into Project Air architecture. Then the main core part is in the red rectangle, right? Where you have your platform that allows you to deploy Internet of Things pipelines right at the edge or in the cloud. You're gonna have your gateway there that knows your sensors and knows your devices, and you're going to normalize that data through HX Foundry, right? And then we also have different bits and pieces powered by our Flogo project. That is an open source project as well. And that is sort of like the integration tool with very small footprint that allows you to glue everything together, right? So you have all these different flows together that allows you to convert data, pass data all the way up to the cloud, and basically create these different pipelines on the fly that deploy dynamically right at the edge on the cloud, depending on what you want. Okay, and then we have also all these different protocols sending data back and forth from the cloud. So I'm going to show you a very quick demo prepared by Marcelo Gallardo that explains a little bit and gives you a little bit more visualization of what it is. Just 1 second.
And some of the images when a particular event is identified are published for further processing by Project Air. More specifically, we have configured the video analytics pipeline to send images when it detects a person wearing a mask. It could have been configured the other way, but for demo purposes, we selected the mask wearing case. Let's look at it. So here in the demo, we can see that I have a camera in front of me, and we have a model that's running and is detecting if I am wearing a mask or not. If I remove the mask, the model detects that I don't have the mask. If I put the mask back, the model detects that I have the mask on. Let's try a few more times. Now, this time, the model, after it executes evaluates the image, it sends the results back to Project Air, and I will show you that next. For this part of the demo, we go back to Project Air's user interface, which presents a summary of the different locations or grouping of devices managed by the framework. These groupings represent a digital twin of the real devices at the edge. Now that the events from the video analytics pipeline were sent and captured by HX framework, we will show a simple flow that has been configured to further process the events generated by the video analytics pipeline. In this simple demo, we simply route those events to the cloud where the events are stored in Air's data store. Let's see how to do it. Let's click the pipeline. This will take us to the pipeline editor. Here we can see a list of all the different flows that have previously been created. We have here one that's called basic file. If I click there, we can also see that the status is deployed. So this is the one I used to capture the video analytics events and save it to their store. So how we did it is we just configure a data source activity that's a subscriber activity, subscribing to the events coming from HX. And then we created a publisher. We created a publisher activity that receives the events from the data source and then just sends to the cloud, where we have another process, the Air process, that is storing those events into Graph database for visualization. Now that we have configured a flow to handle the events coming from the devices, let's go and let's review the details of the devices. So let's go back to the grouping and let's click on the view details. This will take us to a page where it will give us a list of all devices managed by this group. In this case, we can just see a camera that's called DBI OGD camera. And here it gives us an overview of the camera. And also here we have two tabs that has the data that has been received from that camera. One is the snapshots received from the camera, and the other one is the infer results from the model. So if we click on the infer tab, we can see all the different the results that the model generated. So we can see here all this. We can see that we received that the model detected a person with a mask, and also we have some with no mask. We can see it's interleaved when I was wearing the mask and when he was not wearing the mask. And also, if I go to the snapshot, I can see the last snapshot that was received from the camera. And here I can see the image that was evaluated with the mask. And here I have also the result. This concludes the demonstration. If you guys have any questions, please feel free to contact us. Thank you.
Okay, so I know we're a little bit tight on time, so I'm gonna hand it over to you, Jesus. But yeah, a few links in case you want some more information about AIR, Project AIR. We have a GitHub page, and obviously in the TIBCO Labs page, you can see a full set of all of our projects. Thank you very much. Speak to you soon.
Excellent, Miguel. Thank you for that. And you know, on the topic of computer vision, I have a question for you before we wrap up for the day.